In today's video, we're going to cover all 74 LINQ extension methods with examples. We're going to look at which of the extension methods are immediately executed, which ones use deferred execution, what's the difference between them. We'll also cover whether immediate execution necessarily means that the entire enumerable will be enumerated, and various other terminology topics that you really must be familiar with if you're a .NET developer. My name is Amichai, and in this channel, I cover software architecture, design patterns, .NET, C#, also various other tools that will make you more productive as a developer. So if that sounds interesting, then make sure to smash the subscribe button so you don't miss out on future videos. Without further ado, let's jump right in and take a look at our very first LINQ extension method called where. So let's say we have over here an enumerable of type int, let's call it collection, and let's say that this is equal to 1, 2, 3, 4, 5. And throughout the video today, we're going to use the following extension method called dump, and this comes from a package called dumpify. So I have this in a global using over here. This extension method allows you to output basically any object you want to the screen in a well-formatted way. Plus you can see the type over here. So the default that this evaluates into when the left-hand side is an IEnumerable of type int is a read-only array of type int. Okay, so let's start with our very first extension method, which is where. What where gives us is a possibility to filter our collection. So we can go ahead and say where, and over here we can define some predicate where we can say, let's say x is greater than 2. And then if we look at the output, then each one of these elements goes through this predicate. If it equals true, then it'll be in the output. If it equals false, then it won't be in the output, which in our case means that we have only 3, 4, and 5 outputted over here. Okay, moving on to OfType. So let's imagine that we have a collection not only with integers, but we have a collection also with strings in it as well. And let's imagine that we want to take only the elements where the type is int. So we can go ahead and say OfType, and if we say over here int and we say dump, then this will give us only the integers. And if we go ahead and say string, then you can see we get only the string output. Now, if we go ahead and look at the actual value returned from this OfType extension method, and we look at the underlying explicit type, then we can see that it also converts it to whatever type that we specified over here. Right, moving on to partitioning. So starting with skip, this is pretty straightforward. So if we go ahead and say skip 3 and we say dump, then this will go ahead, skip the first 3 elements and output only 4 and 5. If we go ahead and say take instead, then it's sort of like the opposite, right? So we take only the first 3 and we have 1, 2, and 3. Okay, then we have skip and take last. So if we have over here last, and let's give it something over here, then we can see that for the skip last, then we skipped the last 3. And for the take last, it's exactly the opposite. We took only the last 3. In this case, we have 3, 4, and 5. Great, then we have SkipWhile and TakeWhile, which are a bit different. So let's say over here, skip and TakeWhile. And instead of specifying an integer over here, what we need to specify is a predicate. So let's say, for example, while x is smaller than 2, so we specified this predicate, and what will happen is it'll iterate over the collection, and as long as the predicate returns true, then it'll skip that element. So is x smaller than 2? Yes, so we'll skip it. Is 2 smaller than 2? No, so we won't skip it anymore. And then over here, the output is 2, 3, 4, and 5. If we take a look at the take while, then it's exactly the opposite. So it'll continue taking elements as long as the predicate returns true. So is 1 smaller than 2? Yes. Is 2 smaller than 2? No. And then all the rest is dropped, which means that it doesn't matter if over here we have 2 1s. Once the predicate returns false, it takes all the rest of the collection and it doesn't run it against this predicate. So unlike the where extension method, which runs the predicate for each and every one of the elements in the sequence, over here, it only runs until the first time it returns false. Great, then we have projecting. So we have the following 4 extension methods. The first one you're probably already familiar with is select. So let's go ahead and say select over here. And what select gives us is the option to take each one of these elements and project it to a different type, meaning that we can say, let's say for each one of these, let's say to string, and it'll go ahead and turn all of these integers into strings. Now it's important to also be familiar with the following overload that takes an index. So we can go ahead and say the following. Let's say we first want to specify the index, and then afterwards we want to specify the actual value. So as you can see, first we specify the index itself, which will of course run from 0 until the number of elements minus 1. And then over here we have the actual element, which is the numbers that correspond to the numbers that we have over here. Okay, next we have SelectMany. So let's look at an example. Let's imagine that over here, this is not what we have, but instead what we have is a list of integers like so. So what we have is we have here two lists, and in the first one we have 1, 2, 3, and in the second one we have 4, 5, 6. So if we simply use select, then what we have are two elements. The first element is this array, and the second element is this array. If we keep the output the same thing like before, then the I gives us the index, which will stay 0 and then 1, but the element itself is the entire list. One time it's 1, 2, 3, and the second time it's 4, 5, 6, which is why we get this output. If we want to go ahead and flatten these two lists into a single collection, then we can go ahead and use the SelectMany extension method. So let's say over here, SelectMany, and choose the collection as it is. And as expected, this gives us the collection. Okay, now it's important to note that SelectMany will iterate over the sequence, which means that this will be called twice, one time for this and one time for this, and we need to return a collection. What will be returned from that will be turned into one collection, which means that if we also want to turn these to string, then we can't simply go ahead and say over here to string, because this will return two collections of strings. And then when flattening it, then we get each one of the characters like so. Instead, what we want to do is one of the following. Either afterwards call select, and then over here say to string, or if we want it in line, then we can go ahead and say select over here, and then what we have by order of events. So we're turning these two collections into collections of strings, and then we're flattening the two collections, and we get the output like so. Okay, now similarly, also this has the with index overload, so we can go ahead and say x and then x and the current index. And if we want to see what collection this came from, for example, then we can go ahead and say the following. We can say I and then x, and then we can see that the first three came from this collection and the next three came from this collection. Great, next we have cast, which is pretty simple. So cast allows us to cast from one type to another type. So if all of these are of type object and we want to go ahead and cast it to an integer, then we can go ahead and say cast to int, and this will cast it from type object to type int. Okay, next we have chunk. So chunk gives us the following option. Let's say again we have 1, 2, 3, 4, 5 and 6. And we want to turn this into two collections of size 3. So we can go ahead and say over here, chunk, specify 3, and then over here we have two collections where each one of the collections is of size 3, sort of the opposite of SelectMany. So as you can imagine, we can go ahead and say SelectMany, and over here, select X, and this will take it back to the previous form, which was one list with all the items. Okay, next we have existence or quantity checks. I want you to notice that these are the first extension methods that specify that it's immediate execution. So this brings us to a very, very important topic when it comes to LINQ, which is deferred execution and immediate execution. Most of the LINQ extension methods are deferred execution. Where I didn't specify immediate execution, it's deferred execution. For example, this chunk and SelectMany are using deferred execution, meaning that this entire thing won't execute the LINQ query, won't be realized until we iterate over the collection. Meaning that if over here we have result, and this will be the result of this entire thing, and we say result.dump, and then we say result.dump again, then we're performing this chunk and SelectMany twice. So when we go ahead and specify an extension method which uses deferred execution, which is most of the LINQ extension methods, we're only declaring the LINQ query and it's not being executed yet. The only time in which the LINQ query is executed is over here and over here, since the dump extension method goes ahead and iterates over all the various elements because it needs to print it to the screen. So for all the extension methods that I wrote immediate execution, you need to take into account that this specific extension method will execute immediately. And during its execution, it may or may not iterate over the collection. If it iterates over the collection, then it'll go ahead and execute all the various deferred execution LINQ extension methods that we declared beforehand. Okay, now this feature can be very powerful if it's used correctly, but it can also hide very nasty bugs. So let's imagine that over here, we're doing some IO operation. For example, we're reading from the database, or we're making some API call, and we're doing some filtering and sorting based on the data that's returned, but we're not materializing the list yet. Then somewhere down the road, we go ahead and say to list twice. So let's imagine that this is hidden behind some client that returns some objects in an IEnumerable form, but it's not realizing the list yet. Then what we have over here are two API calls, twice the logging, twice the latency, twice everything that we're doing. To avoid this, what you want to make sure is that if you're using the same LINQ query twice, you go ahead and materialize the list before you use the LINQ query. And then what we have over here is the list and not an enumerable. And then this over here, first of all, it's redundant, so you don't need it. But also, even if you do call it, then it won't go ahead and execute the entire LINQ query again. So this is very important. So every time you see immediate execution, take into account whether it'll iterate over the entire list. And if yes, make sure that you're using it wisely. Now, all of these three will go ahead and iterate over the collection, but it won't necessarily iterate over everything. So for example, any checks if there's a single element or more that passes the following predicate. So for example, x is greater than 2, then what will happen is 1 will go through this predicate, 1 is not greater than 2, 2 is not greater than 2, but 3 is greater than 2, which is why this entire thing returns true. Once we return true from one of the predicates, then it won't go ahead and iterate over the rest of the collection. Okay, next we have all. All is similar to any, but exactly the opposite. So all will check if for every single one of the elements in the collection, the predicate returns true. So because not all of them are greater than 2, then what we'll have over here is false. But if we change this to something like 0, then we can see that the output is true because all of the items are greater than 0. Okay, next we have contains. So contains gives us the following functionality. So we can go ahead and specify over here an element, and it'll check if the element is part of the collection. Okay, then we have sequence manipulation. So if we want to go ahead and add a 7 in the end or a 0 in the beginning, then we can go ahead and say the following. We can say append 7, and we can also prepend 0. And then if we look at what we have, so when we appended the 7, then we have 1 until 7. And when we prepended the 0, then we have 0 up to 6. Okay, now real quick before I continue. So as you can see, I'm creating here a README with all the various examples, etc. The source code is available for my patrons. If you want to join, then make sure to check out the link in the description, which has the link to the Patreon, which includes the source code of this video alongside every other video on this channel. Okay, let's continue to aggregation methods. So if we want to know the count of elements, so basically how many elements we have in this collection, then we can go ahead and call count, which will give us the number of elements in the collection. In our case, it's 6. Now count is immediately executed, and based on the underlying collection, it's implemented in different ways. So you can imagine that if we have behind the scenes an array, then it'll simply call the length property. But if it's unknown, it's simply an enumerable, and we haven't executed the LINQ sequence yet, so we don't know what the underlying count is, then it'll go ahead and iterate over the entire collection to get the count of elements. So if we have something like the following, we say where x is greater than 2. So in this case, count isn't as trivial as simply fetching the value in one of the properties in the collection, but we actually need to do for each over all the elements and count how much we have. If we want to get the count only when we already know the count without actually enumerating over the entire collection and realizing the LINQ query, then we can go ahead and use the TryGetNonEnumeratedCount method with a crappy name, which can be used as following. So let's say over here, TryGetNonEnumeratedCount, and let's say out var count, and let's dump the result of this to the screen. So as you can see, we get here false, and that's because the where over here creates a new enumerable that isn't realized yet. And to understand what the count is, we need to enumerate over the entire sequence. And because this method will only do it if it's already computed, then this entire thing returns false. On the other hand, if we remove this where, then because the underlying type of this is a read-only array of integers, and the count is already known, we don't need to enumerate over the entire collection to understand what the count is, then this entire thing returns true, and the count will contain the number of elements, similar to what we had before. This basically gives us the functionality to only count the number of elements if it doesn't require enumerating over the entire collection. Okay, next we have max. So if we go ahead and call max, then it'll compare each one of the items over here, and they'll find the biggest one, which is 6. This also receives a predicate, so you can go ahead and say x times -1, for example, and then it'll go ahead and multiply each one of the elements by -1, and it'll find you the maximum, which in this case will output -1 because -1 is greater than -2, -3, etc. If we simply update this to MaxBy, which is the next one, then instead of -1, we get 1. So basically what we have is we're using this to do the comparison, but we're returning the underlying element that corresponds to the element that computed to the highest value. Now, this is actually used more often in the following scenario. So let's say we have over here some person, and this person has a name and an age, and we have 2 people. The first one is you, and you are 15, and the next one is me, and I am 16. If I want to find the oldest person, so what I can do is say people, and then I can say MaxBy, and I can go ahead and access the age, and this will give me the person with the higher age, which is me. And I'm sure you can see why this is useful in this case and not Max, because Max, like we said, will go ahead and change the actual object, and that's what will be returned. Now, real quick before we continue, I want to remind you that I have 3 comprehensive courses on Dome Train. 2 of them are a 0 to hero in clean architecture, which comprise, in my opinion, the most comprehensive course for building production-ready applications following clean architecture, including tests, authorization, everything you need to know when you're building production applications, and also another course on domain-driven design, which also I don't think there's another comprehensive course like this course that teaches you everything you need to know to get started with domain-driven design, so all the various terminology, various concepts, core concepts, and principles that you need to know when you're working with domain-driven design. So if you enjoy these videos, you want to expand your knowledge on clean architecture and domain-driven design, and you want to see more of this on your screen, then make sure to check out the link in the description. Now back to the video. Okay, so this was count, TryGetNonEnumeratedCount, max and MaxBy. Next, we have min and MinBy, which are very similar, so I'm not going to talk too much about that. So we have min, which will basically give us the smallest element in the collection, which in our case is 1. Again, if we specify a predicate over here, then it'll go ahead and manipulate the actual objects. If we don't want to manipulate the actual objects, then we can go ahead and say MinBy. Okay, next we have sum. So sum will go ahead and sum all the various objects that we have. So the sum of the values that we have is 21. But as you can imagine, this extension method doesn't work on any type of enumerable. So if we had over here an object, then we can't go ahead and sum an object, which is why this won't work. And behind the scenes, what we have is basically various extension methods for the specific underlying types. So this is for IEnumerable of type int, and we also have other ones for double, etc., etc. If we did have an object over here and we wanted to sum, then we can go ahead and say x, and then let's say x, and let's convert this to an integer, and then we can go ahead and sum it like we did before. Okay, average, same story. So pretty simple, sums the entire thing, divides it by 6, and gives us 3.5. And before we talk about aggregate, I do want to talk about LongCount. So LongCount, pretty similar to count. So same story like before, return 6 because we have 6 elements, but the difference is that the return type is long. Last, but definitely not least for this subsection, is aggregate. We're going to talk about 3 overloads of the aggregate extension method. This is, in my opinion, the most underrated extension method in LINQ. So let's talk about it. We have the aggregate extension method, where what it has is the following. So let's say we specify over here x and y, and we say x plus y. So let's say this is the function that we're passing to the aggregate extension method. And the way I like looking at it is as following. So the first iteration is a special iteration where the x will be 1 and the y will be 2. So x plus y will simply be 1 plus 2, which is 3. And then for all the rest, then we can look at it like a sliding window where the y will be every time the next index, and the x will be replaced each time with the result of calling the function. So when we're looking at 3, then the sum of 1 and 2 is 3. So we're doing 3 plus 3, which is 6. And then when we move on to 4, then the sum is now 6. So we go ahead and do 6 plus 4, which is 10, etc., etc. And finally, until we get to 21. So this will sum all the various elements that we have. Okay, another example is, let's say we want to turn this entire thing into a CSV. So we want to have 1, 2, 3, etc. So what we want is to put a comma between the 1 and the 2. And then we want to continue putting a comma, and then the next element, and then a comma, and then the next element until the end. So what we can do is the following. First of all, let's go ahead and turn each one of the elements into a string. So let's say x.toString. And then what we can do is we can go ahead and say x, comma, and then y. and the output is as we expect. The next overload I want to talk about is the following. So let's return to the previous example where we're simply doing x plus y. So what we can do is we can specify some seed value. So for example, we can say over here 10, and then instead of the first iteration x and y being 1 and 2, then the first iteration is 10 and 1, and it continues the same thing like before. Similarly, there's another function that we can put in the end where we go ahead and do something after we aggregated all the various values. So let's say after we finished aggregating everything, we want to go ahead and divide it by 2. So we can go ahead and do the following. We can say the seed is 10, and then like we said, we have it 10 and 1, and we're doing 10 plus 1, then we're doing 11 plus 2, etc., until the end. Then in the end of that entire execution, we have 31 like we saw. Then we can specify a function that gets this value and does something on it. In our case, we're dividing it by 2. Meaning that if, for example, we want the average, then we can say the seed is 0, which means that by the end of this entire thing, then we have the sum of all the elements. Then we can go ahead and say x divided by collection.count, which will give us the number of elements that we have in our collection. And because we're dividing two integers, then we're losing the remainder. So we can say over here, simply float, which will give us float divided by int, which won't lose the remainder. And then over here we have the average, which is 3.5. So that's Aggregate, a really powerful extension method. If you're not familiar with Aggregate, or it still just doesn't make too much sense, then rewind and watch this small subsection again, because I think it's very powerful. And once you're familiar with it, then I'm sure you'll find various places in your application that it makes sense to use it. Okay, moving on, we have first and FirstOrDefault. So if we say simply collection.first and then dump on this, then as you would expect, we get the very first element, which is 1. Now the problem with this is that if the array or the collection is empty, then we throw an invalid operation exception, meaning that when you call first, you must have at least one item in your sequence, in your collection. Otherwise, it'll throw an exception. If you don't want it to throw an exception, then you can go ahead and say FirstOrDefault, which if the collection is empty, then it'll return the default for your specific type. In our case, it's int, so it's 0. If you want to go ahead and specify your own default type, then you can go ahead and say over here, let's say -1, and then if the collection is empty, then it'll return your specific default instead of the default for that type. Okay, next we have single and SingleOrDefault. So this is pretty similar to the FirstOrDefault, but with a small nuance. So let's imagine we have 1, 2, and 3. And now we call single. Single, unlike first, doesn't give you the first no matter how many elements you have in your sequence. Single expects you to have only one element in your collection, meaning that if we call single currently, then it'll throw an exception because we have more than one element. So if you wrote some LINQ and you know that by this stage you must have only one item in your collection, then it makes sense to call single and turn that single item in the collection to the item itself. If we had more than one element, then again, we throw an exception because we don't have exactly one element. Now you may be thinking to yourself, okay, this is pretty simple. If we want to solve this, all we need to do is say SingleOrDefault. Then you're wrong. This will still throw an exception because SingleOrDefault will throw an exception when there's more than one item. But if there are no items, then it'll return the default for your type, which in our case is 0. So again, SingleOrDefault, when the collection is empty, then it'll return default. When the collection length is 1, then it'll return that element. And if the collection length is more than 1, then it'll throw an exception. If when the collection length is 0, you wanted to return a different default and not the default of that type, then similarly, you can specify over here the default that you want to return. And in our case, because there are no elements, then it'll go ahead and return this default. Okay, next we have last and LastOrDefault. So this is very similar to the FirstOrDefault, but from the end. So if we go ahead and say LastOrDefault, then it'll return the last element when there's a last item. But if it's empty, then it'll return the default that we defined, which is -1. And if we simply call last, so this will throw an exception because the last expects there to be at least one item. And as we can see, so we get this invalid operation exception, sequence contains no elements. Okay, next we have ElementAt. So if we have here 1, 2, and 3, and we say ElementAt, and we specify 1, then it'll give us the element at index 1, which in our case is 2. If we specify something that doesn't exist, so I'll say index number 12, then this throws an index out of range exception. But if we don't want it to throw an exception, then we can go ahead and say ElementAt or default, which will return the default for our type, which is 0. Okay, next we have DefaultIfEmpty. So if you go ahead and add DefaultIfEmpty, so this will go ahead and do nothing when your collection is not empty. But if it is empty, so let's imagine that we don't have anything in our collection, then it'll go ahead and add a default element. So currently we have 0. Okay, now I want you to notice that this is using deferred execution, meaning that we're not evaluating anything here yet. Okay, next we have all the various to array, to list, to dictionary, to hash set, to lookup. All of these take our collection, they materialize the collection into a different type of collection. So if we want to go ahead and turn this to array, then we can go ahead and say to array, and we add some values, then we can see that we have an array outputted to the screen. If we want a list, then we can go ahead and say to list, and this will turn it into not an array, but a list. If we want a dictionary, then we can go ahead and say to dictionary, and we can go ahead and specify what is the key and what is the value for each one of the elements. So let's say that the key is simply the number, and also the value is the number, like so. So maybe the naming isn't the best, so I change this to key and value. And as you can see, the key and the value correspond to what we defined over here. So again, both this and this will be each one of the elements, and we can specify how we want to convert it to the key and how we want to convert it to the value. Okay, next we have to hash set. So to hash set will go ahead and turn our collection into a hash set. Okay, finally we have to lookup. So for this example, let's create again the person record. So I'll say record person, and let's give it a name and an age. And let's say we want to create a lookup table between the age and the people associated to that age. So we can go ahead and say to lookup, and let's specify over here that we want to do it based on the age. And looking at the output of what we get, then we can see we have a lookup table between the age and a grouping of the person. So over here we have two groups. One group contains only you because you're 15. And over here we have me and them, which are 16. Now, if we want to go ahead and access the underlying objects, so we can go ahead and access the group of people who are the age of 15, which is only you. So we can go ahead and say over here, single. So this will go ahead and return the single object in the grouping of 15, which is you, meaning that we can also say over here, let's say name and access the underlying name of the single person, which is 15, which is you, and the output, as we would expect, is you. Okay, next, let's talk about generation methods. So these two simply cast the collection to an IEnumerable or iQueryable. Not very interesting, so let's look at that real quick. So let's say we have over here, let's say a list of people. So now if we have this collection and we want to turn it into an IEnumerable, then all we need to do is say var, let's say foo, and we can say collection.asEnumerable, and this will no longer be a list of person objects, but it will be an IEnumerable of person objects. If we go ahead and say as queryable, and we look at the type, then now it's iQueryable and not list. So pretty straightforward. Okay, the following three are actually very interesting and very useful. If you're not using it yet, then you definitely want to be familiar with this. So let's imagine that we want to create an enumerable from the numbers 0 until 100. Then for that, what we can do is we can go ahead and say enumerable of type int, and let's call this again collection. And we can go ahead and specify every single number from 1 until 100, or we can go ahead and use the range method. So we can go ahead and say Enumerable.Range, give it the start index and the count. So this isn't very intuitive. I always get this wrong, but it's not the start and the end index. So if you say 3 and then 6, it won't give you 3, 4, 5, but it'll give you 3 and then 6 elements. So 3, 4, 5, 6, etc. So let's say we give it 0 and we give it 100. This will give us an enumerable with the numbers 0 until 100, meaning that if we say now dump, then we get all the numbers until 100, not including. So again, this is the count. So we said 0 and then we want 100 elements. So including 0, it's 0 until 99. Repeat is very similar. So we can go ahead and say repeat, and repeat will simply repeat this value 100 times. So we get 100 zeros. If we don't want anything, then we can go ahead and say Enumerable.Empty. And of course, we need to specify the type over here. So let's say that it's an integer. And this will go ahead and create an empty enumerable of type int. Now what's good is that if you look at this method, then you can see it's static. So if you, in various places around your application, you're using Enumerable.Empty of an int, then you're not creating new lists every time or new collections every time, but you're using or you're referencing that same static collection in the enumerable class. Okay, next we have various set operations, or at least that's the title that I gave it. So starting with distinct, so let's say we have over here the following. We have 1, 2, 3, and 1. What distinct will do is it'll go ahead and get rid of the extra 1, and it'll give us a distinct of each one of the values. Then for the distinct by method, this is very similar to the other xby methods that we saw before. So again, let's say we have over here some person, and alongside the regular values, then we also have some ID. So let's say it has some int ID in the beginning, and we have, for some reason, the same person twice. So we have me twice. Then we can go ahead and say distinct by, and we can specify the ID, and this will go ahead and get rid of the duplicate person with the ID of 1, like so. Okay, next we have various operations on two enumerables. So let's imagine we have here two enumerables. Let's say collection 1, which will be 1, 2, and 3, and collection 2, which will be 2, 3, and 4. Okay, now real quick, if you're not familiar with set operations, so let's imagine we have over here the two collections represented by two circles. So let's say collection 1 and collection 2. The intersection between the two collections will be the items that are in both collections, meaning in our case 2 and 3. So let's say over here 2 and 3. Then what we have over here are the rest of the items that aren't in collection 2. So in our case it's simply 1. And over here same thing, but the items that aren't in collection number 1, which in our case is 4. Okay, now what we have over here are various methods that allow us to select various numbers based on this logic. So for example, if we're talking about union, union is basically combining both of the circles. So this will be this entire thing, which will include 1, 2, 3, and 4. So if we call union, we'll get the combination of the two sets where each one of the items is distinct. Intersect will give us only what's in the middle. So in our case, it's 2 and 3. Finally, we have except, which is only what's over here. So you can imagine it as taking collection 1 and subtracting from it all the elements that appear in collection number 2. Then I say I messed up the order over here, but we have the by version of each one of the union, intersect, and except extension methods. So let's see it in action. So let's say collection 1, union, collection 2. As we said, this will give us everything. So we're expecting to see here 1, 2, 3, and 4. Great, as we expect. Next, we have intersect, which we expected to give us only what overlaps, which is 2 and 3. Next, we have except, which like we said, is subtracting collection 2 from collection 1, which in our case, we get only 1. Okay, then we have the by versions of these three. Okay, so very similar to what we had before. So I created a person with an ID, a name, and an age. And if we look at the two collections that I created, so the first one contains both you and me, aged 15 and 16 with the ID of 0 and 1. And the second collection has a person which is you. If we go ahead and call UnionBy the ID, then we'll get only you and me. As you can see over here, so this is the output for union. If we go ahead and call IntersectBy, then we get the single item which is in both of the collections, which is you. And if we go ahead and call except, then it's like subtracting the two collections. So as you can imagine, because collection 1 has me, but collection 2 doesn't have me, then the output is me. Okay, next we have SequenceEqual. This is pretty straightforward. So this checks if the two sequences equal one another. So if we have 3 collections, let's say the last one has also 4, and we go ahead and compare collection 1 to collection number 2. So because they're equal, we're comparing each one of the items per index. So because they're equal, then we get true. But if we go ahead and compare this to collection number 3, then we expect to get false. So as we expect, we get false. Okay, next we have joining and grouping. So this is really great features that you need to be familiar with. So let's say we have collection 1 and collection 2. And let's say that collection 2 is actually not ints, but it's strings. So let's say we have over here A, B, and C. So what zip allows us to do is to go ahead and create pairs. So basically, if we want to go ahead and create pairs where we have the following pairs, so we have one pair with 1 and A, the second pair with 2 and B, and the third pair with 3 and C, then we can go ahead and say collection 1, and we can go ahead and zip it with collection 2. And then if we go ahead and dump the output, then we'll see that we're creating 3 tuples where each one of the tuples is a pair corresponding to the index. So the first tuple will have item 1 and item 2 being 1 in A, and the last one, as we can see on the screen below, will be 3 in C. So we have a tuple with the values 3 and C. Okay, now if the 2 collections aren't in the same length, so let's say over here we have 4 items and not 3 items, then you can see we still have here 1A, 2B, and 3C, and this D is simply ignored. If we have only 2 items, then what do you think will happen? Well, we get only 2 items. We have 1A and 2B. So you can imagine we're creating pairs until the length of the shorter collection between the 2. Okay, now you can actually do this with more than 2 collections. So you can also go ahead and say over here something like the following, and you can specify collection 2 and also collection 3. And as you would expect, we have here a tuple now with 3 values, 1A and asterisk, etc. Okay, next we have join. Join is very similar to join in SQL. So if we have, for example, again, a person, let's say record person, and similarly it has the ID, the name, and the age, but also we have some product that they bought, and this contains the person ID and let's say the name of the product, and we have a collection of the people and the products. So same drill, we have you with the index of 0, me with the index of 1, and for the products, let's say we have, let's say shoes, pants, and glasses, where basically these indexes are the person that bought this product. So over here we have the shoes and the pants being bought by you and the glasses being bought by me. So if we want to go ahead and join these 2 collections, then we can go ahead and say join collection 1 with collection 2. Then in the people, we want to go ahead and use the ID as the property we want to join the collections on. And for the products, then we want to go ahead and use the person ID. Okay, finally, after we joined the 2 collections, then we want to go ahead and take the person and the product. And let's say we want to create a string where we're saying person.name bought product.name. Okay, and as we expect, we get here you bought shoes, you bought pants, and finally me bought glasses. Great, so that's join. Looking at GroupJoin, so this is actually very similar. If we go ahead and replace this with GroupJoin, then we no longer have here just one product, we have an IEnumerable of all the products. So we can go ahead and say, turn this into products, and then we can go ahead and say products, and over here, let's say string.join, and let's join via comma all the various products. And as you can see, instead of having 2 lines for you, then there's 1 line where the value is the collection of all the items from collection 2. Great, moving on to concat. So let's revert to a simple example again. So let's say we have 2 collections over here where collection number 1 has 1, 2, 3, collection number 2 has 4, 5, 6. If we want to go ahead and combine these 2 collections, put them one after the other or concatenate them, then all we need to do is say collection1.concat and collection number 2. And if we dump this, then we simply get the numbers 1 to 6. Okay, next we have GroupBy. So I reverted back to one of the examples that we had before where we have a person with a name and an age. And over here we have 3 people. If I want to go ahead and group all the people that have the exact same age, then I can go ahead and say the following. I can say collection, then I can say group by, and I can group by the age. And what this will do is it will create 2 groups, one group with only you because you're 15, and the other one is me and them with the age of 16. Now, if you're not familiar with the grouping type, then let's say we're taking only the last group. So we can say last group. This group object has only one property, which is the key. So we can go ahead and say last group, and we can say key and dump, and this will give us the key of the last group, which is 16. Now you may be asking yourself, how do I actually see the values in the group? Well, in this case, if we look at the underlying type, then you can see that all we have over here is an IEnumerable, meaning that what we can do is we can go ahead and iterate over the grouping. So we can say for each, let's say person in last group, and we can go ahead and say person.dump, and this will dump the person to the screen. So we can iterate over it like any other enumerable. Okay, next we have sorting. So if we want to go ahead and sort the collection, let's imagine this is actually 3, 1, and 2. And we want to go ahead and order the collection, then we can go ahead and call order, and then we can dump it to the screen, which will simply order it being 1, 2, and 3. If we want to do something more interesting, then we can go ahead and say order by and do over here whatever we want. Okay, now this example doesn't make a lot of sense, but if we have objects, then we can go ahead and order by a specific property in the object. So if we have many people and we want to order them by age or by whatever, then we can go ahead and use order by and specify the property that we want to order by. Okay, so that's order and order by. Let me just fix the order. Okay, so that's order and order by. Moving on to order descending and order by descending. So if we go ahead and add descending over here and over here, then we get the exact same thing, but in a descending order. So 3, 2, 1 instead of 1, 2, 3. Okay, then we have ThenBy and ThenBy descending. So after we order it based on one property, then we can go ahead and order it by another property. So for example, if we have over here some person, which is 25, we have another John aged 23, and we also have a Mary aged 28. If we want to go ahead and create a list where they're ordered alphabetically, so basically we have J coming before M, but then we want to go ahead and order it by age. So we want John, which is 23, to come before the John, which is 25. Then we can go ahead and do the following. We can say order by and specify over here that we want to order by the name. And then we can say then by, and this time order by the age. Then as we expect, we get John 23, John 25, and finally Mary 28. If we want the inner ordering to be descending, then pretty simple. All we need to do is say then by descending. This will flip the order of the two Johns, and we'll have your 25 and then 23. Last and yes least, so we have the option to reverse a collection. So if we have, for example, 1, 2, 3, then we can go ahead and say reverse and then dump. And as you would expect, the output of this entire thing is simply 3, 2, 1. Okay, finally, as a teaser for the next video, so there's also something called parallel link, also referred to as plink, which gives you the option to do things in parallel. So very similar to parallel.forEach, and then you can do actions on a collection in a parallel fashion. So similarly, you can do this with LINQ. This is a very powerful feature that most people aren't familiar with, so we'll do this in a separate video where I'll cover all the functionality that you can do with plink. So if that sounds interesting, make sure to smash the subscribe button so you don't miss out on that video when it comes out. So that's it for this video. I hope you enjoyed it and you learned something new. I'm reminding you again that I have 3 comprehensive courses on clean architecture and domain-driven design. So if you enjoyed this video, then make sure to check out those courses. You may enjoy them as well. Make sure to smash the like button, smash the subscribe button, and I'll see you in the next one.